Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we're going to learn how to solve radical equations and how to apply this skill. It's actually quite easy. A lot of skills that we have seen before. The main concept of the equation solving is the same. Okay, the equations are asking you to solve for the unknown. So basically, the procedure is more or less the same. A radical equation, though, is an equation that has a variable in a radicand or a variable with a rational exponent. Remember, if I have like x to the 2/3 plus 5 equals 9, remember that's the cube root of x squared. So I can put it in radical form, or I can put it in exponential form. In this lesson, we are going to assume that all radicals and expressions with rational exponents represent real numbers, okay? Now, because we're going to also learn about the complex number system soon, so this is dealing with real numbers. Procedure for solving an equation with one radical is very simple. First of all, isolate the radical. Kind of like when we were doing the absolute value equations, we wanted to isolate the absolute value. This time we want to isolate the radical. Okay, we don't want anything being multiplied to it. We don't want anything being added to the outside of it. We don't want anything being divided to it. Okay, we want to get it alone. What does that look like? I don't know. Maybe you've already simplified it where it's the square root of 3x plus 2 equals, I'm just putting a number there, 8. I have isolated the radical. If I have a plus 5 here, I'm going to have to subtract that 5. If I have a 7 here, I'm going to have to divide by 7. If I have a 5 down here, I'm going to have to multiply by 5. I want to get that radical alone. Number 2, cancel out or eliminate the radical by raising both sides of the equation to the power of the index. Remember, this is something we've learned already as well. If I have a square root of x squared, the power of 2 cancels out that radical. What do I have to raise something that's in a cube root? I raise it to the 3rd power. Okay? They cancel. Now, you may say, why, Mr. Morrow? Well, isn't the cube root of x equal to x to the 1/3? What happens to x to the 1/3 when I raise it to the 3rd power? What do you do when you multiply, when you raise a power to a power? You multiply a power. So what's 1/3 times 3? X to the 1st power, which equals x. So that's the mechanics behind it. That is why it works. So whenever you have any index or any root, any radicand with any root, you want to get rid of that root? Raise both sides of the equation to that power. Does that make sense? Okay. Now, step 3, solve the resulting equation and check for extraneous solutions. Extraneous solutions, again, are solutions that look as if they're real, but when you go ahead and plug them in, they don't work. So they are solutions, but they're solutions that don't work. So let's get to it. It's not that difficult, my friends. A, let's solve this equation. I want to get the radical alone. So what do? Add 5 to both sides. So I've got the square root of 4x plus 1 equals 5. How do I get rid of this square root? I don't multiply anything. I raise both sides to the 2nd power. The square root now gets canceled with that power of 2, and I have 4x plus 1 equals 25. Subtract 1 to both sides now. 4x equals 24. Divide both sides by 4. X equals 6. Let's do a little check on it. 4 times 6, because that's what x is 24. Plus 1 is 25. Square root of 25 is 5. 5 minus 5 equals 0. Bingo. That is a real solution. It works. No problems. Does that make sense? Pretty simple, right? Yeah, I figured. Okay, number 2, what do we got to do first? Thank you. Subtract that 3 because I want to isolate the radical. So I got 2x minus 3 and a square root equals 5. How do I cancel out a square root? I square both sides. I raise both sides to the second power. So I got 2x minus 3 equals 25. Bless you. Add the 3. 2x equals 28 divided by 2. X equals 14. Does that make sense? Talk to me. You look a little confused. You want to sit closer? Okay, come on up. Sit closer. Bring your chair. Excuse me for 1 second. Okay, now we got that taken care of. All right, C. What do we do? Subtract 2. Yes, very good. Boom. So I got the square root of 3x plus 10 is equal to 2. How do I get rid of the square root? Square both sides. Thank you. Cancels the square root. I got 3x plus 10 equals 4. Subtract 10 to do both sides. 3x equals negative 6. X equals negative 2 because I divided by 3. And boom, we're done. Now let's see if it works. Negative 6 plus 10 is 4. Square root of 4 is 2. 2 plus 2 is 4. Boom, works. And we didn't check this one up here either. 14 times 2 is 28, minus 3 is 25. Square root of 25 is 5. 5 plus 3 is 8. Works. Okay, D. Subtract 7 at both sides. I got the square root of 5x minus 1 equals negative 2. Okay, what do I do now? Wrong. You do nothing. It's no solution. Actually, that's wrong as well. There's no real solutions. We're going to learn soon how to have a negative square roots. But right now, can the square root of any number ever be negative? No. So therefore, this is no real solution. Just like the absolute value, remember? If you have the absolute value of 2x plus 5 equals negative 6, it can't be, because you cannot have an absolute value that is negative. Does that make sense so far? Yes, sir. Ah, you are genius. Great question. Let's say that was a cube root. Would we be able to do it? Absolutely. Because a cube root can have a negative answer. The cube root of negative 8 is negative 2. Great thinking. In fact, if the index is odd, it doesn't matter what it equals. It could equal a positive or negative. But if the index is even, the equation must equal a positive number. Very good job. Very good job. Excellent. Okay. Let's continue. A little bit more, a little bit more challenging, but still easy. Okay, the radical is isolated. What do I do? How do I cancel out this radical? Square. Now, please be careful here. This is x plus 5. This is not x squared minus 1 squared. It is not. Please remember that means x minus 1 times x minus 1. So when we FOIL this, we got x squared minus x, that's negative 2x plus 1. Subtract the x, subtract the 5, create a trinomial. X squared minus 3x minus 4. What times what is negative 4, but when added together is negative 3? Negative 4, positive 1. Very good. Guys, remember we've already done this? Zero product property. What do I have to do? Thank you very much. You said each of these equal to 0. So x will equal 4 or negative 1. Now let's see if it works. 4 plus 5 is 9. Square root of 9 is 3. 4 minus 1 is 3. 4 works. 5 minus 1 is 4. Square root of 4 is 2. Oh. Negative 1 minus 1 is negative 2. Negative 1 is extraneous. My only answer is x equals 4. Do you see that, guys? I'm sorry, sir? I subtracted the x to both sides, and then I subtracted the 5 to both sides. Yes, sir. Thank you. So that way I can set it equal to 0. Okay, B. It was funny you asked about the cube root. Here we go. I got negative 4 to both sides. Please do not fall into the trap, okay? Although this is a negative 3, we can go forward because it is a cube root. Odd roots can be negative. Now, how do I get rid of a cube root, gentlemen? You cube both sides. You don't cube root it. You cube both sides. So I got 3x minus 12 equals negative 27. Thank you so very much. Add that 12, sorry, to both sides. Solve the equation. Come on, Morrow. 3x equals negative 15. Divide by 3. X equals negative 5. Bingo. And for those, you don't have to check them, because it doesn't matter if it's going to be negative or not inside. I mean, you can. You got negative 15 minus 12, that's negative 27. Cube root of negative 27 is negative 3. Negative 3 plus 4 is 1. It works. Yes. Yes. You're not going to have extraneous solutions there. Okay. I got the cube root of 3x plus 1 equals negative 2. I want to get rid of a cube root by cubing both sides. So that's going to give me 3x plus 1 equals negative 8. Subtract the 1 to both sides. 3x equals negative 9. Divide by 3. X equals negative 3. Bingo. Done. And if you plug it in, negative 9 plus 1 is negative 8. Cube root of negative 8 is negative 2. Negative 2 minus 4 equals negative 6. It works. Make sense? Pretty simple? Okay. Now, sometimes, like I had told you before at the beginning of the lecture, sometimes equations contain fractions that have rational exponents. Fractions that have rational exponents. That is weirded incorrectly. It should say variables that have rational or fractional exponents instead of radicals. In order to solve the equation of this form, you can convert the rational exponent into a radical. You can just go ahead and convert it and just make your life easy. Or you can isolate the variable with the rational exponent and then raise each side of the equation to the reciprocal of the given power. It really doesn't matter to me. I'll show you what I mean right now. Here, I would divide by 3, of course. So I have x plus 1 to the 2/3 equals 4. Now, I can convert this to a radical, make it the cube root of x plus 1 squared, or I can go ahead and raise it to the 3/2. If I raise it to the 3/2, this goes bye-bye, and I got x plus 1 now equals, this is the square root of 4 cubed, right? Right, guys? The square root of 4 cubed. What's the square root of 4? 2 cubed is, so x plus 1 equals 8. Subtract the 1 to both sides. X equals 7. This is the easier way to go. The much easier way to go. If they give you a rational exponent, this is much easier. But it is up to you. Your choice. B. Subtract 3 to both sides. And I've got 5x to the minus 1 to the 1/2 equals 7. I'm going to go ahead and multiply by the reciprocal, which is 2 over 1. Raise it. So now I got 5x minus 1 equals 49. Add the 1. 5x equals 50. Divide by 5. X equals 10. If you plug it in, 50 minus 1 is 49. Square root of 49 is 7. 7 plus 3 is 10. Does that make sense, guys? Okay. I'm going to skip C because I'm running short on time, and I got to move on. Is that fine? Is that fair? Thank you, gentlemen. Okay. Because I got to get to this. Procedure for solving equations with two radicals. When you have two radicals, same procedure, guys, not a big deal. Isolate, though, just one radical. Do not try to do this with both radicals on the same side. It is going to be a mission. Isolate one of the radicals. Cancel out or eliminate the radicals by raising both sides of the equation to the power of the index, and then solve the resulting equation and check for extraneous solutions. So this actually is not too bad. I've got a cube root and it equals another cube root. So I already have them both individually on their separate sides. Let's get rid of this cube root. How do I do that? Cube it. Bam, bam. So guess what? Now I got x squared minus 4x minus x equals negative 3x plus 2. We know how to do this already. Set it equal to 0. Add 3x and subtract 2 to both sides. Add 3x and subtract 2 to both sides. So this is x squared minus 5x plus 3x. So that's 2x, negative 2x, minus 2 equals 0. Did I do that right? Yeah, I think I did. Yeah. Unless this number should have been something else, which I think it may have, because I can't really factor that, can I? I cannot factor that. You don't have the skills yet to factor that. So that x should have been actually, let's see, to have a 2 there, should have been actually, no, should have been straight up a 6. That should have been a 6, guys. That's going to make things a lot easier. Sorry about that. Because you guys don't have the skills yet to do this. So let's make that a 6. So you can have something cohesive here. So when I subtract the 6, of the 2 from the 6, then it gives me x. Oh, actually, now I screwed up again. X plus, there's going to be minus x. That's 8. No, it can't be 8 either. Darn it. I screwed you up here. Let's do this. You got to this point. If that happens, at this, geez Louise, at this point in your mathematical careers, you don't know how to solve that, so you would just leave it like that. Done. Okay? I'm not going to do that, but if that happened, it would just be done right there. Okay? Now, here comes the complicated part. What happens when I have something like this? I isolate one of the radicals. Absolutely. Good job. So I've got the square root of, and this should be an x, not a y. Wow, a lot of mistakes. Sorry. 3x plus 6 equals square root of x plus 6 plus 2. Square both sides, and this is where you got to be careful. This cancels, and that's just 3x plus 6. That's easy. But guys, this becomes the square root of x plus 6 plus 2 times the square root of x plus 6 plus 2. So you have to FOIL this. What's the square root of x plus 6 times the square root of x plus 6? X plus 6, thank you. Good job. Then I have square root of x plus 6 times 2, and then I have 2 times square root of x plus 6, so that's plus 4 square roots of x plus 6. Are you with me? And then I have 2 times 2, which is 4. I'm going to lower this so we have plenty of space. Is everyone with me so far? Okay. So now I've got 3x plus 6 equals 10. So I've got x, bless you, plus 10 plus 4 square root of x plus 6. Let's go ahead and subtract an x and a 10 to both sides. So I have 2x minus 4 equals 4 square root of x plus 6. Let's go ahead and divide everything by 4. So I have x over 2 minus 1 equals, actually, you know what? Let's not work with fractions. Don't do that. Don't work with fractions with this, because that's going to make your life miserable. At this point, I need to get rid of another second square root. So what do? Square both sides. So I have 2x minus 4 times 2x minus 4 equals, this squared becomes 16 times x plus 6, because 4 squared is 16, and this 2 cancels out that square root. Now let's FOIL. I got 4x squared minus 8x, damn it, is minus 16x plus 16 equals 16x plus 96. Subtract the 16x to both sides. Subtract the 96 to both sides. I get 4x squared minus 32x minus 80 equals 0. From here, I can divide a 4 to both sides, giving me x squared minus 8x minus 20 equals 0. And then from here, this is x minus 10 times x plus 2 equals 0, x equals 10, and negative 2. Huh? And then we would plug that in to see if it is viable. Okay, now, damn it. Go ahead and do the homework. We'll go over the applications tomorrow. The applications are not that hard. Read, and we'll talk. Thank you, guys. Have a great day.